got an interesting little repair job to do here. It's a dry flange of a car. Actually goes to a double bearing, a wheel bearing, and what's happened is that's been running slack and it's actually worn the material away there. That's original size and that's all wear, that lip there. There's one or two marks in where they've been a little bit overzealous cutting the inner track off, but that won't really affect anything. I've welded these up before, weld up there, remachine it, and the problem you get when you weld it is it shrinks and it gets a really tight fit on the splines. So what I'm going to do is mount it in a 4-jaw chuck, machine some of this away, and I'm going to bronze weld it, or TIG braze it, or with some silicone bronze rod. I'll fill these holes in as well, and then remachine it back to size. This is quite an expensive part, and it's worth spending a bit of time repairing it. Getting back to this taper on here, I found there was one or two little marks on, little high spots. I stoned those off, and now when I put a chuck on, it goes on dead accurate, dead true. So basically that's been the problem all along. Clean it up, put the 4-jaw chuck on. I've also found that how you tighten this on is quite important. So what I do now, I nip it up like that, and I give it 2 blows with a dead hammer, and I find that gives really good repeatability and accuracy. Right. I'll clean that face up there. I'll just clean that face up on a wire wheel, then we'll mount it. That face up against the chuck drawers and just clock in on that face. Right, first thing we do is find the high spot, which is that one there. And tighten that. Next high spot, which is that one. It's got a kick on it because it's got a mark where it's been caught with a grinding wheel. Getting near. It's within a couple of tenths, 2 to 3 tenths. If you ignore that kick there, go from there around to there. That's just high spot there. Right, that's as good as it's going to get. I want a fairly rough finish on here. This one gives the brazen material something to key to. And basically that'll do. So there's some nasty marks in here where it's been caught with the grinder, but they have no effect on it. That pushes into the bearing, it makes no difference at all. Just doesn't look nice. One thing when I weld it, I'll make sure I've got an earth actually onto here. I'll wrap some copper cable around there and get a good earth onto the piece. I don't want to try earth and throw the headstock bearings on the lathe. That will be a total disaster. I started to edit this video last night and I noticed when I was editing it that this is not running true. I clocked it in on that point there to be within half a thou thereabouts, actually closer than that, but it's still not running true because I didn't clock that face in there, which means it's actually pissed in the chuck. It's not in the chuck straight. I put a clock gauge onto that face there. See, we've got run out. We've got quite a lot of run out as well. 5 thou. So what I'm going to do, I'm going to set it up, true again, reskim this, braze it up and then machine it. So once again we'll go for our highest point, which is there. Bring that back round to there. We'll give it a little tap. Once again, highest point, which is there. Highest point there. Getting somewhere near now. High point there. Right, that's pretty good. Now what I'll have to do is check the run out on there again. I've moved the gauge around to a different, obviously a different plane. You can see how far that is. So once again we'll find the high spot, which is there. Tighten that one. We won't tighten, so we'll loosen the opposite one. Tighten that one. High point once again, which is there. I'm getting somewhere near now. High point. Right, that's within less than half a thou anyway. We'll check the other angle again. Right, the gauge is in the other way, and that's within a few tenths, less than half a thou. So now we'll know this is running true. I'll run it up, and now this bit here should run true, and the bit I machined obviously should run off. Right, that piece there's obviously running dead true and that bit's running off. And so I get an interrupted cut there. Full cut there. So now we know it's running true. That's how far off at it. Which is enough to make a massive difference on something like this. I didn't need to show that, but if I didn't show it, somebody would point it out to us, and I knew after watching the video it was wrong, and I never point out my mistakes. Right, I've managed to weld it up, or braze it up. Brazed quite nicely, nowhere near as much heat as welding. One thing I've decided to do is make a weld positioner, definitely. like a rotating table type thing, possibly even motor driven. A reduction gearbox and a windscreen wiper motor or something, just to so I can sit well at the bench and just press a pedal and it'll turn an eighth of a turn or whatever as I'm welding. Right, we'll dress it up now and see what sort of results I've actually achieved. In fact, that'll be cool when I have a nice cup of coffee. But wanting it would be have it cool when I have a cigarette, but those days are no more, thank goodness. Machining quite nicely. It's machined very much like copper, but it is bronze. It doesn't really matter if there's small gaps in it, as long as it's got a good surface for the bearing to sit onto. It's a press fit into a bearing. As I've already said, I have welded these before, and when it cooled down it shrunk that much that you couldn't get the splines in on the drive shaft end. But it's had nowhere near as much heat on this time using the bronze welding. So there is one or two, there's quite a few misses in it. Not ideal, but it'll still work. It's the first time I've actually used this rod for this type of application. I could re-weld that, but honestly it doesn't need it for what it's got to do. It's very near size now. See, I'm not really happy. I'm debating whether to weld it back up again and fill the gaps in, because the bits that where there's no gaps is good, but it will not affect the way the bearing runs. Absolutely spot on, same size. I'm probably going to get Loctited into the bearing. I'll bring the camera in and show you the finished result. That's it there. You can see there's one or two places where I haven't got enough rod in. One there, but there's plenty area for the bearing to go on to. I've got no doubt it'll run perfectly alright. These grooves here that somebody's put in with a grinder, they don't make any difference really. It doesn't look nice, but anybody that knows how a car type wheel bearing works, it's taper to taper, press fit bearing. The bearings are pressed, they're just pressed into a bearing, one taper one way and one the other way. Once again, it's just time to say thanks for watching, thanks for subscribing. A massive thanks, as normal, for all the well wishes that are still coming in towards my wife and my dad.